In the last video, we explained the basics of cell biology, genes, and epigenetics, which means we're now in a position to create a model of how cancer comes to be, how it grows, and how it spreads. We do this by presenting a 6-part model. This is important as it provides a basic framework for understanding not only how drugs work, but also how other interventions like exercise, diet, and reducing stress might work against cancer. We want to empower you to help yourself. Many sources talk about cancer in 3 stages: initiation, promotion, and progression. But this doesn't help you understand what's actually happening at the cellular level, which means it can't help you assess whether a particular intervention is worth the effort. So, to combat this, we are going to give you a 6-part model. You've heard of the Magnificent 7. Well, this is the story of the Maleficent 6, cells misbehaving and gaining abilities they shouldn't have. These are the hallmarks of cancer. Doctors call them pathways, as they are the routes through which cancer acts. The first hallmark is that cells divide when they shouldn't. They become independent and no longer rely on cues from their environment to start or stop dividing. Then, they refuse to commit cell suicide or apoptosis when told to. And finally, they gain the ability to multiply endlessly. Most healthy cells will only divide a small number of times and then stop. But cancer's natural multiplying process has no end, leading to uncontrolled cell division and tumor growth. But there's another side to this equation. The cells aren't just acting alone. They take cues from 2 different messengers: hormones, such as estrogen and testosterone, and growth factors such as insulin-like growth factor and vascular endothelial growth factor. But let's shorten these to IGF and VEGF. They're a bit like a turbo on a car. They accelerate growth. Okay, so that's the first part of our model. On we go. Just like us, cells need nutrients to live and divide, which they obtain from the bloodstream. But the problem for tumors is that they aren't always in direct contact with it, particularly as they get bigger. If the billions of cells that make up a tumor can't access nutrients, they'll starve and die. So, to combat this, they evolve. They learn to tell the body to create new blood vessels. This process is called angiogenesis. A word that's 5 syllables too long in our view. You can just think of it as food. The third hallmark of cancer cells is that their metabolism has changed. You can think of your metabolism as the sum total of all the chemical reactions that happen in your body, all day, every day. The body is essentially a chemical machine. It converts glucose into energy using oxygen. This is one of the many millions of chemical processes constantly happening in the body, allowing us to live. But scientists studying cancer have noticed that cancer cells can actually sustain themselves in low or no oxygen environments. In other words, cancer cells have different metabolism to normal cells. Inflammation is the 4th hallmark of cancer. Cancer absolutely thrives in an inflammatory environment. Chronic inflammation is bad and is one of the things you need to think about when considering lifestyle change. Just as a poor diet and no exercise can promote inflammation, a good diet and lots of exercise is thought to reduce it. The 5th hallmark relates to the immune system, which doesn't function properly against cancer, although it does slow its growth. The immune system has a hard time recognizing cancer as a foreign enemy. It is, after all, a mutated form of our own cells. It's also thought that cancer cells give off signals telling the immune system they should be spared execution. They are wolves in sheep's clothing. That said, the immune system does still delay cancer's advance. We know this for a couple of reasons. First, those with compromised immune systems are overwhelmed far faster by cancer than those without. And second, we know that certain parts of the immune system, in particular natural killer NK cells, do attack and destroy some cancer cells. Still, it doesn't work as well as it could. And it's new immunotherapies that currently hold the greatest hope in terms of developing more effective cancer treatments. They normally involve removing immune cells from the body and re-engineering them to identify and kill cancer cells. The final hallmark of cancer is that cells gain the ability to move from one location to another. This is called metastases and is the deadliest aspect of cancer. Cancer is much easier to treat when it is found in a single, confined location. Here, surgery and radiation are very effective. However, once cancer has spread more broadly in the body, systemic treatments like chemotherapy are needed, and they tend to be less effective. The exact process of how metastases occur is itself complex and beyond the scope of this introductory video series. We are now in a position to better understand how drugs and other interventions might stop or slow cancer's growth. For example, the last decade has seen the development of numerous drugs that cut off cancer's food supply, acting on the second pathway. These include big names like Avastin, Nexavar, Sutent. They are known as angiogenesis inhibitors. Many other drugs act on pathway 1. For example, a relatively new group of drugs called kinase inhibitors interfere with cell multiplication. Others block hormone or growth factor action to slow cell growth. This is common in hormone-driven cancers like prostate or breast cancer. But it's not just in understanding drugs that this model is helpful. It can be applied to everything. For example, in terms of lifestyle, exercise is thought to lower hormone levels and reduce inflammation, while certain foods, such as turmeric, are thought to do the same, as well as have potential anti-angiogenic properties. But we will come back to all of this in future videos. The model gives us a common language to talk about cancer, whether discussing treatments with doctors, considering lifestyle changes yourself, or trying to understand whether a particular emerging or complementary therapy is worth it. In addition, there's a metaphor that we find helpful when thinking about cancer and the best way to respond to it. And that is that it's a bit like a tug of war. On one side, you have forces acting for cancer, DNA damage, gene mutation, inflammation, and so on. By the time someone is diagnosed, they have normally been growing in strength for years, even decades, so are a formidable force. On the other side, you have the big guns of treatment, like radiation, surgery, chemotherapy, and so on. They are generally strong, and they are going to work against the cancer. Curve is all about figuring out whether you can strengthen your team further. I should now be clear, we think that exercise, diet, and stress management are important team members. And there may be many others from the worlds of emerging and complementary therapies. They will be considered in a later video series. We don't know how effective these things are. It will vary from patient to patient. All we can tell you is that, based on the available science, they should be considered. It's a delicate balance, but the aim, of course, is to tip it in your favor.